read this, there's going to be a couple things that will happen. One, they'll give you the equation. Most of the time, they won't. Most of the time, they will give you this right here, and they will ask you, write the equation. Then they'll ask you to interpret the slope, interpret the y-intercept, interpret r, or they'll ask you to find r. So we did this question, you guys, when we did chapter 3, we did a question like this. So again, constant is your y-intercept. Arm span is your slope. Now we're going to talk a little bit about what everything else is. Okay. So, so this is the standard deviation of the residuals. This is going to be the standard error of the slope. This is right here. This is the standard error of residuals. Slope, standard error of the slope, standard error of the residuals. Okay, so those are things that you need to know.
What don't we need to know?
You probably don't need to know this.
I think from T-ratio.
The T-ratio, I'm going to tell you what that is. So the T-ratio, this is your test statistic. Okay, so and the test statistic you use is this one right here. So if I ask you, what is your test statistic? This is your test statistic. So let's go. This is your slope. This is the standard error of the slope. This is your test statistic. And then this is your p-value. So there isn't a lot of stuff that you do in your calculator. They're going to give you computer output. So you have to know what everything means. Okay. And then this is your standard error of the residuals. This is r squared. We don't use r squared adjusted. We use r squared. And remember, that's a percent. So to find r, what would you do? Take the square root. Okay, so let's just make sure we know again. Okay, so what's the constant? Y-intercept. What's the in this problem, what does arm span? What does this number mean? Slope. And that, you guys, it doesn't matter whatever computer output you look at, that will always be slope. Okay? What is this? Standard error of slope. This test statistic, and then this is your p-value. Now, if your p-value is less than your alpha level, what do? Reject it. If your p-value is greater than your alpha value, what do? Fail to reject. Those things still haven't changed. It's just now where are you finding that information? Okay.
When you get r from r squared, are you doing the square root for this one? Could you do the square root of 84.8 or 0.848?
0.848.
Okay.
So when you're finding r, change that to a decimal and then take the square root.
So under the P, it also has a value that's 0.000.
No, it's not, it's this one. This right here, that is this one right here is your p-value, not the top one.
Yeah, so how is it 0? Does that mean there's just...
It's so small. You know how like sometimes our calculator gives us all these numbers and then it says e to the like 20th, right? That's what it's saying. It's saying it's so close to 0, so they just rounded it. Yeah, because we've gotten some of the sign. Remember when we find the p-value, the calculator puts it in scientific notation, and it might be e to the -8. Well, that means there's 7 zeros before that number, so you would just round it. So it's so close to 0. That's why. And you guys, again, you're not going to look at anything in the top row. It's just always that slope. Okay. So I want to look at another one to see what our slope and everything like that, so we can look at that. Okay. Okay, so here's another piece of what we call computer output. You guys are so talkative today. You're making me feel warm and cozy. Okay, so first thing that I want to do is we need to write the equation for the least squares regression. That's the first thing that they're going to ask you. They give you computer output. So what is the least squares regression line?
You need to put it in context.
Yes, you will need to put it in context. They didn't do a very good job, did they? Researchers wanted to know if having a larger proportion of physicians in developing African countries is associated with a higher average of life expectancy. Data for 10 African countries were entered into a statistics package and regression analysis was requested. Here are the results. Note that the explanatory variable is population physician ratio, which is defined as the population divided by the number of physicians. So that's what ratio means in this context. So we can use ratio. Okay. So we want to know higher average life expectancy. So the proportions of physicians in developing African countries is associated with higher average life expectancies. So what is, first of all, let's just talk about what is my y-intercept.
54.948.
Okay, so the y-intercept is 54.948. And then what is the ratio? What does the ratio mean? Yeah, so the ratio is our slope. Now, what do you notice about the slope, you guys?
Negative.
Okay, so now this is really important because they are tricky. I don't want to say they're tricky, but this is the things that they like to do. If my slope is negative, what will my R be? What will my correlation be? Negative. So when you take the square root of R squared, you need to make sure you make it negative because remember correlation, your R always matches your slope. Okay? Okay, now I'll give you a better one in a second. What does this number mean right here? 0.0001461. Okay. Standard error of what? Okay, slope. What don't we have?
Test statistic or
So we don't have a test statistic or p-value. So that means they're not available. So there might be another way that we can do it. And I have a formula for you. And there's also, you guys, they do give you this formula on your reference sheet. Okay. And then what is this number?